Welcome to The Explainer. Today, we're diving into one of the absolute most profound mysteries in all of science, the search for extraterrestrial life. And we're going to be exploring this through the fascinating perspective of physicist Brian Cox. Now, this isn't your typical talk about flying saucers and sci-fi tropes. No, this is a real, grand cosmic detective story. It spans billions of years, mind-boggling distances, and the very nature of existence. So let's jump right in and look at the clues the universe has given us so far.
So, are we truly alone out there? I mean, think about it. We are looking out into a universe packed with countless galaxies and literally billions upon billions of stars. And yet, we're met with a deafening silence. This incredible tension between the vast amount of potential real estate for life out there and the complete, utter lack of neighbors calling us up, well, that's the core of what's known as the Fermi Paradox.
Section 1. The Fermi Paradox Problem.
To really get a handle on this, let's look at the sheer, massive scale of our cosmic timeline. As Brian Cox points out, we actually only have one single data set to base our guesses on, and that's our own history right here on Earth. The universe formed roughly 13.8 billion years ago. Then, Earth formed about 4.5 billion years ago. And life? Well, life actually got started pretty quickly after the Earth cooled down, roughly 4 billion years ago. But here is the absolutely critical clue. It took 4 billion years to go from the origin of simple life to a civilization that could, build a telescope or launch a rocket. That's nearly a third of the age of the entire universe. If that incredibly long, fragile timeline is typical, it suggests something huge. It implies that while simple microbes might be popping up everywhere, complex, intelligent civilizations could actually be exceptionally rare.
And it gets even trickier when you actually look at the stars themselves. Take red dwarfs, for example. They are by far the most numerous stars in our galaxy, and they burn for a very, very long time. But because they're relatively dim, planets have to orbit incredibly close just to stay warm. And being that close means they become tidally locked. Basically, one side of the planet is perpetually baked in harsh radiation, while the other side is just a frozen, endless night. That kind of extreme temperature contrast? Yeah, not exactly prime real estate for a thriving, complex ecosystem.
Section 2. Searching close to home.
So where do we actually start looking? Well, right in our own cosmic backyard, we're focusing on two prime candidates in our solar system, Mars and Jupiter's moon Europa. Mars is definitely the world we understand the best right now. We actually have powerful evidence that 4 billion years ago, right around the time life was kicking off here on Earth, Mars had conditions very similar to ours, complete with ancient rivers and oceans. In fact, we have the Perseverance rover rolling around there right now, taking samples we eventually want to bring home. Then you've got Europa. It looks like a frozen ice ball, but beneath that crust is a massive, long-lived saltwater ocean with active geology. We've got missions like NASA's Europa Clipper and the European Space Agency's JUICE heading out there soon to investigate. And here's why this matters so much. If we find even simple microbes in either of these places, a completely separate second genesis of life right here in our own solar system, it would be a massive neon sign implying that the universe is just teeming with simple life.
Because at the end of the day, life, when you really strip it down, is basically just incredibly complex chemistry. And the ingredients for that chemistry are actually surprisingly common across the cosmos. You need water to act as a solvent, you need some active geology, you need what chemists call redox chemistry, which is basically just a way for electrons to move around and do work. And of course, you need amino acids, the building blocks of life. We've actually found those scattered all over the place, even writing on meteorites. A lot of biologists agree that if you put these common ingredients together under the right conditions, the chemical pattern of copying, things like DNA or RNA, just happens naturally. It's essentially just chemistry looking for a place to land.
Section 3. Biological or machine intelligence.
Now here's a thought that might challenge your assumptions. When we picture alien visitors, we almost always picture biological creatures, right? But honestly, our biology is incredibly fragile. We age, we get tired, and we require these massively complex life support systems just to travel to the nearest planet. We literally did not evolve for the harsh, unforgiving environment of deep space. Now compare that to a machine-based intelligence. If a civilization survives long enough, it seems highly probable they'd eventually transition beyond their original biological bodies. They might upload their consciousness into something silicon-based. A digital or machine intelligence wouldn't age. It would effectively be immortal, completely capable of enduring interstellar journeys that take thousands of years. They might even send out self-replicating von Neumann probes to map out the galaxy. So, as Brian Cox suggests, any advanced aliens we might one day find, and frankly, humanity's own distant future, will likely be digital, machine-based entities.
And to really grasp why that kind of immortality is an absolute must for space travel, just look at this number, 7,000. This brings in the totally mind-bending physics of Einstein's special relativity. See, the laws of physics don't actually forbid you from traveling between galaxies. If you could somehow build a ship that goes 99.99999% the speed of light, relativity tells us that distances literally shrink from the perspective of the traveler. So that massive 2.5 million light-year distance to the Andromeda galaxy, it would shrink by what's called a gamma factor of 7,000. So purely on paper, it's physically possible, but realistically, traveling that close to the speed of light is completely off the table for our current biological and technological limits. But for an immortal machine intelligence, hey, they've got all the time in the universe.
Section 4. Defying Hollywood Alien Stereotypes.
Now, obviously, whenever we talk about aliens, the conversation inevitably turns to unidentified aerial phenomena, or UAPs, and the massive theories about government cover-ups. But Brian Cox takes a really pragmatic, skeptical stance on this. Just looking at the logistics impartially, keeping a secret of that sheer magnitude would require a level of strict, flawless organization that, let's be honest, governments historically just do not have. Plus, there's actual sociological research backing this up. The more people who know a secret, the exponentially faster it leaks. So the idea of a flawless, decades-long cover-up involving thousands of people, it just really doesn't align with how human organizations actually work in the real world.
And while we're on the topic of Hollywood myths, why do aliens always seem to have 2 arms, 2 legs, and 2 eyes? Honestly, you can blame 1960s television budgets for that. Back in the days of early Star Trek, it was simply way too expensive to create aliens that weren't just a human actor in a rubber suit or wearing some heavy makeup. Now sure, some biologists will argue that bilateral symmetry, like having 2 eyes, is a really common evolutionary trick for depth perception, which is super handy if you're a predator. But given that life on another planet would have evolved under completely different gravity, completely different atmospheres, and totally unique chemical conditions, real alien biology would likely be so wildly unrecognizable to us that we might not even immediately realize we were looking at something alive.
Section 5. The meaning of the search.
I want to bring this all together with an absolutely beautiful, poetic realization. A physicist is a hydrogen atom's way of learning about hydrogen atoms. Just let that sink in for a second. 13.8 billion years ago, the universe started off with mostly just simple hydrogen and a little bit of helium. And then, fast forward through billions of years of stars exploding, planets forming, and chemistry brewing, and that exact same primordial hydrogen has somehow organized itself into complex, conscious beings, us, beings that can build telescopes, figure out the laws of relativity, and look back in time to understand our own origins. We are quite literally the universe becoming conscious and trying to understand itself. It's an absolute miracle of existence when you think about it. Which leaves us with this final, pretty profound question to ponder. As we send rovers out to scratch the dirt on Mars, as we prep missions to dive into the icy oceans of Europa, and as we scan the skies for the faint signals of some immortal machine intelligence, are we really just looking for aliens? Or is the search for extraterrestrial life ultimately humanity's own deep quest to understand our incredibly rare, beautiful place among the stars? It really makes you wonder, if we are currently the only advanced civilization in the Milky Way, maybe looking out into the cosmos is just the universe's ultimate way of looking back at itself. Thank you so much for joining me on this explainer today. Keep looking up and never ever stop being curious.